Hello and welcome to this video tutorial. Today we're going to look at the problem terminal velocity. Now in this terminal velocity problem, okay, you're going to be given some information about an object. You'll be given its density, its diameter. Now you'll need to convert that into radius and then convert centimeters into meters. You'll be given the drag coefficient, the air density, the gravitational field on that planet that the object is falling. Okay, we will need the drag formula, which you can see is written right here. 1/2 times rho, which is the air density, not the density of the object, times the C sub D stands for drag coefficient, times the area, okay, the cross-sectional area of the object, and the velocity squared. All right, so the first thing you should do, go ahead and put your name into the program, and let's go ahead and begin. You're going to be prompted with all this information, and then from that, you can see what we're going to be doing is we ultimately have to find the mass of the object, the acceleration due to gravity, and the terminal velocity. Okay, so what I'm going to do is I'm going to begin by copying down my information. You go ahead and copy down yours, and we'll begin our problem. Okay, once you have that written down, it's probably a good idea that you write down the equation for drag because you're going to need it. So the drag force, right, is equal to 1/2 times rho, that's the air density. Okay, 1 second. Times, let's see, 1/2, okay, 1/2 times rho, that's the air density, times CD, that's the drag coefficient, times A, which is the maximum cross-sectional area, times V squared. Now, V is actually going to be terminal velocity in this case because we're looking for the velocity when the force is balanced or when the object stops accelerating. But really, that's just going to be velocity just in general. So we'll be looking for that. Okay, so in step 2, show the calculation for the mass and the force gravity. Well, here's the thing. We're going to need density, okay? So if density is equal to mass per unit volume, we can see that mass is going to be density times volume. So what you're going to have to do is you're going to have to take the density times the volume, because you better figure out the volume. Well, that object is a ball, so it's a sphere. So the volume is going to be 4/3 pi r cubed, or you can go 4 pi r cubed divided by 3. That's an easy way to accomplish that. So you see we need the radius. So let's go back to our information table, and let's get the radius. You have the diameter. The radius, of course, would be half of that. So in my case, 12.6 divided by 2 is 6.3 centimeters, but we need to rewrite that, and that would be 0.063 meters. So make sure that you convert your diameter to radius and then change centimeters to meters. So 0.063, so 4 pi times 0.063 cubed divided by 3. Let's figure out what that volume is. Okay, so for mine, I'm getting a pretty small volume of about 0.00105 cubic meters. Okay, so now if I take that information and I multiply it times density, I will have my mass. So that's how I'm going to figure out my mass in kilograms. Okay, so the density is 2526 kilograms per cubic meter. and the volume was calculated at 0.00105 cubic meters. You see that cancels. 0.00105 times 2526. And I'm looking at a mass of about 2.65 kilograms. Okay, so there's my mass to begin with, 2.65 kilograms. Now I can also find the weight. The force gravity is the weight, right, which is equal to m times g on that planet. Please don't use 9.8. G is going to be whatever you wrote down here. So in my case, 2.65 kilograms times 5.6 newtons per kilogram. The force due to gravity, which is the weight, is about 14.84 newtons. Okay, so there's my force gravity, 14.84 newtons. Okay, I'd be fine if you rounded it to 14.8, okay, or round yours to the 10th if you want to, if you don't want to decimal points. So show the calculation for the cross-sectional area of the ball. Now this is the maximum cross-sectional area of the ball, which would essentially be the entire, would encompass the entire diameter of the ball. Okay, which the cross-sectional area would of course be a circle, right? And the area of that would be pi r squared. So that's what we're going to do right now. We're going to go pi times 0.063 squared and for me, I'm getting a maximum cross-sectional area of 0.0125 square meters. Okay, so now what we're going to do is we're going to show how we calculate the velocity of the object. Now the velocity of the object in this case is terminal velocity, because at terminal velocity, what's happened is the weight going down balances the drag force going up, which is 1/2 rho times the drag coefficient times A times V squared, right? So all that. But this is balancing this because the acceleration has dropped to 0. Okay, the acceleration was negative 9.8, but it's dropped to 0. Okay, so we got to take that equation, D equals 1/2 rho CD A times B squared. Just make sure I got the whole equation. Okay, and I want to solve this equation for V, which means I need to get rid of 1/2 rho CD A n squared. So I think the first thing I'll do is I'll go ahead and multiply by 2, get rid of the fraction, and I have 2D equals rho times the drag coefficient times A times V squared. At this point, we can divide by rho CDA. And then lastly, square root. So V, which is the terminal speed, is the square root of 2 times the drag force divided by the air density times the drag coefficient times the cross-sectional area A. Okay, just plug into that. Okay, so the drag force, remember we just talked about this, the drag force is equal and opposite to the weight. So however much weight you have, this is the same thing as the drag force, right? They're the same. So 14.84. Okay, now I want the air density for rho, so 0.572. Times the drag coefficient, which is 0.479. times A, the cross-sectional area, 0.0125. Go ahead and take a moment to put that in your calculator. See if you can get a value for terminal speed. All right, I'm getting a value of about 93.1 meters per second. Okay, and there we go. Hopefully you were able to get this correct yourself. If not, try again. If you're still stuck, of course, please come and see me so I can help get that resolved for you. Thank you. See you next time.